And this is basically what you will see within the project. You'll have the project name or ID, and then the configuration files, the important Python files, the model files, the pickle file if required, right? All those things will be stored within this folder. This can be also on GitHub, and you will also be able to call the model from GitHub repository as well. Over internet, we can try and trigger the execution. You just pass the URL. And -p is the parameters. Either you can pass the command like this, or you can run like this, mlflow.run, and then do this. So there are different ways to trigger the job, and you'll get the artifacts that we can capture. All right. So packaging format, basically, it can be in local folder or GitHub repository. It basically captures all the dependencies, right? And then it ensures that the code is run, and the code, we can basically trigger the jobs in Python, R, Java, command line, right? All these things can be used for triggering your jobs. This is how the jobs can be triggered. MLFlow space run, that's all. All you are going to do is MLFlow run. The idea is to ensure that this code package can be run anywhere. Okay, so that's the idea. This is for remote execution. As I said, we will be using the link, the location where you have the GitHub code, and then the server that we want to run. We will pass the details, and then it's executed. Okay, so yeah, let me push it. So these are the phases. If you trigger your job, you'll say MLFlow run. It captures all the details. It's like you're downloading the content and trying to ensure that the environment related packages, versions, right? All those things are updated, and you're basically having an environment which is ready with all those dependencies, right? It creates a environment, conda environment, for example, and virtual environment, and within that, it ensures that all those things are ready. It also does the packaging of your dependencies using conda.yaml file. YAML is a configuration file, like XML. Yet another markup language, that is YAML. And even in Kubernetes, we use YAML files for configuration related things. And here as well, it uses YAML files. So it creates the YAML files, which defines the configuration of your machine learning. And then it can be used for running anywhere. So these are the steps that we have seen. So create the project, right? We define the entry points. Then we ensure that we create the Python code package with everything. This will then go into your configurations. So conda.yaml file will basically document the configurations. It records all the dependencies and everything, right? And basically everything is getting packaged together, and you will have YAML file with the information. Then you will have a repository. You're going to push your project into that repository. And when you want to run that code, you can directly connect to that particular code repository and then trigger the MLFlow run command. Right, so these are the phases. The idea is to have reproducibility, shareability, and flexibility. Reproduce means it can be run with different, it can be run on different environments. So development environment, test environment, production environment, but be there. The code should be able to reproduce in all these environments without any issues. And we should be able to rerun that, right? We should be able to experiment the executions as well. Then shareability, again, the point is the same. People will have different location or hardware requirements, software requirements, code repositories, etc. So the ML code that we are basically coming up with should be shareable. It is easy to share my code with you so that you can run it anywhere. What environment you will use, we don't know. So the code should also be flexible to execute it in any different environments. These are the high level 3 points that we look at. It's in short, it is reproducibility that we are trying to look at. Right, so load, ETL, ML, and model training. This is the life cycle basically, and MLFlow tries to take these independent steps and package them together. Okay, and this is how your code looks like. We'll see the code. Don't worry about the code. We'll see the code. And with respect to module 3, which is models, deploy machine learning models in diverse serving environments. So we have trained everything, we have packaged, but where do you deploy it? Right? So that is basically taken care by the models. Again, deployment can be anywhere. It could be on local machine or on cloud. Right? So we'll be able to support all of this. But MLflow models will also be able to tell which is the best model that you want to deploy. All you're doing is going into that folder, taking everything which is packaged by the project phase and pushing that into your, or serving that into your environment, serving environment. So log model, save model, load model, and deploy model. Okay, so those are high level commands that we will be using. You can see here, this is a Keras model. So you'll have .h5 format as the saved model. Right? So that is under your data. Conda.yaml is the configuration details, configuration file, and you have ML model, which is used for building the model, right? That's the code. This code basically gave us the best model. Okay, so this is basically how you will see the content. So ML model, this is first run, this is second run. And depending on what model you are going to call in, you will have specific MLflow libraries that can be used. For example, here you can see MLflow.keras. That means this is Keras model that we are trying to train. MLflow py function. This is more generic. You can use any of your Python function to execute your training job. But if you're using sklearn, for example, you can have this like, right, this model. So MLflow.py function is more like a generic command, and within that, in place of py function, you can put any of your libraries that you can prefer or you want. So that's basically your